Hi everyone, today we are focusing our lesson on solubility, and we'll start talking about dissolving and how that process works. So when we talk about solutions, I just want to remind you all that we have two parts, right? The first part is the solvent, and this is the main thing that's dissolving the other stuff. And then you've got your solute, which is all the other stuff that's being dissolved. So this table is just showing you that we often talk about these two right here, liquid dissolved in liquid or solid dissolved in liquid. But there are also other examples of solutions that could be gas dissolved in liquid, for example, is soda. Gas can be dissolved in gas. The air we breathe is a mixture of gases. And other examples like solid dissolved in solid. Brass and steel are what we call alloys, made up of different elements, often metals. Okay? So make sure you understand there are many kinds of solutions or homogeneous mixtures. Okay, so remember the solute is what we have less of in. So just, watch the video, pause it, and test yourself. What's the solute in each of the following solutions? So here we have less sugar being dissolved in water. In this second, we have two alcohols. The lesser amount is going to be your solute. In letter C, we have salt being dissolved in water. So this salt will be the solute. And what about this last one? I'll have you do air. What's the solute in air? You'd be surprised to know that our air we breathe in is not mostly oxygen. So what's the solute here? All right, if you said oxygen is the solute, you are correct. We have less oxygen in air. The air we breathe is actually mostly nitrogen. Okay, so nitrogen would be the solvent. All right, you're going to watch a short little video on the dissolving process. Make sure you pay attention to the different positive and negative charges. Particularly, we're looking at water and salt. Okay? So as you just saw, the formation of a solution, how water breaks apart a salt crystal. Basically, the different charges interact with one another. So on the surface of our salt crystal, the polar water molecules are attracted to the charges on a salt crystal. And so as we can see here, the oxygen is attracted, so the oxygen is slightly negative, and it's attracted to the positive sodium On the right side here, we see the slightly positive water being attracted to the slightly negative chlorine. Okay, so that's kind of the gist of what you should know when water dissolves a salt. So when water does dissolve a salt, you can see that it breaks up into these ions. So the solid salt crystal, S is solid, breaks up into ions. And so when they're dissolved in water, we use these two letters AQ. So what does AQ stand for? That stands for aqueous. And that means it's dissolved in water. Okay, so basically it's just saying that when salt dissolves in water, it breaks up into sodium and chlorine ions. We get the separation of ions. Okay, so I just want you to think about these examples here. Does it dissolve? So water and salt, what do you think? Does that dissolve? It's pretty obvious, yes. What about water and oil? Does that dissolve? I think this one's pretty obvious as well. No, it does not dissolve together. Oil and salt. So think about when you've had Korean barbecue and you get sesame oil with salt and pepper, one of my favorite dipping sauces. What do you think? Does this dissolve? The correct answer is no. These do not dissolve. So what determines if something dissolves or not? Well, we like to use this rule in chemistry: like dissolves like. So what that means is similar substances will dissolve in the same thing. So ionic and polar solutes dissolve in polar solvents. The main one, of course, being water. Okay? So salt will dissolve in water because they both have charges. Nonpolar substances will dissolve in nonpolar solvents. So oils will mix together. They dissolve in one another. Right? So I have a jar of different oils that I reuse after I cook. So I've got olive oil, bacon fat, and I just reuse these oils and they all just mix together. And because they're both nonpolar, then they do dissolve in one another. Here's another example, and this will lead us to our demonstration. What do you use to remove nail polish? Okay, so nail polish remover, of course, which is also known as acetone. Now think about it. Is this substance going to be polar or nonpolar? I want you to answer this one. What about a styrofoam cup? Is that going to be polar or nonpolar? Here's a little hint for you here. Remember, polar substances do dissolve in water. So does a styrofoam cup dissolve in water? All right, so check out the demonstration as I combine these two things. Hey everyone, I'm gonna show you what happens when we take a styrofoam cup and I've got some acetone here, and we're gonna combine them and see, well, will it dissolve? So let's check it out. Here's my styrofoam cup and my acetone. There goes my styrofoam bowl. It's been reduced to goop. And there you have it. styrofoam bowl in acetone. Ugh. Lastly, just a couple key terms here. Miscible is when two liquids can mix together. Immiscible is when liquids cannot mix together. This sounds like mixable to me, so that's how I remember these words. So oil and water are what we call immiscible. Okay. What about one more example here? You tell me if these two things are miscible or immiscible.